Hey guys, Spencer at Z1 Off-Road, coming to you from the dyno bay today, one of our rare quiet days, so we're happy to take advantage. We're looking at a new product for the late model Titan. Our vehicle's equipped with that VK56 VD engine. This is pretty much 16 plus. Had a lot of requests for more tuning and upgrade parts from you guys, so our team's addressed it. I think they've done a great job. Why is an upgraded coil something that matters? Well, that's something that's definitely worth covering. It's not a new concept. Hot ignition coils have been around since the hot rod era, and we're here for it. Certainly ways to improve your vehicle and confirming that you're going to have good ignition at the set-off of the spark, and you're going to have good enough burn energy through the duration of the burn cycle. And the power stroke is important, so you have partial misfires, breakup, or anything like that. Covered the technical on this in a previous video. We'll kind of show you some of those details now. Okay, Nissan, in their infinite wisdom, has chosen to make ignition coils in different shapes and sizes, connections, mounting solution. They're different for almost every engine. Some engines even have 2 different part number coils on the same engine. Thanks for that, guys. Very exciting. But even though we may think it'd be nice if they were a little more uniform, we know that there's not a one-size-fits-all coil solution for this market. You got to make sure you have something mounts correctly, stays in place, works like it's supposed to, and doesn't require any other modification, patch harnesses, hardware changes, tuning, anything like that. So Z1 coils, they check all those boxes. They're simple, fit, OE quality, higher output, and they bolt right in. So if you can change spark plugs, you absolutely can change your coils. Nothing else will be needed to reap the benefits. We don't change anything crazy in the coil. The concept here is not new science, as we mentioned before. This has been mainstream popularity, I'd say, since everybody started racing cars. In our system, we don't have like an old school big old can coil and cables that have to run over to control the primary from a distributor with points, and then cables to run the secondary voltage back over to the distributor cap. It's then got to transfer to a rotor button and back over other cables, and then finally onto a spark plug. No. Lucky for us, modern era, we have coil on plug. They're transistorized ignition. What that means for you is that none of the other stuff has to be replaced, and the chance of a problem with it is far less. Your ECU has been developed extremely heavily to run well in hot, cold, dry, wet, moist conditions. Different barrows, all kind of scenarios have been poured into it, and you're not going to have to deal with any changes outside. Just like the OE, we operate the same. We've just beefed up the coil windings. In total, we use about 20% more copper in our ignition coils than the OE. We don't mind putting in the extra investment because we're not buying millions at a time. The good news for that is it will work just the same. So a power source here, when we turn our car on, we send power over to both coils, windings in the coil. We have a primary side and a secondary side. On our primary side, ECU will control the transistor to ground the circuit. When it grounds that circuit, we will get flow of electrons and current, which will generate an electromagnetic field. This whole process is known as the dwell cycle of a coil. That's charge times. We're talking milliseconds, just a few milliseconds, right? ECU says, hey, light it up, and then it will break this ground when it wants to fire at the right time. All the purpose of this is trying to time that spark so that we get firing at the right time and get the most pressure on the downward stroke, on the power stroke, at the right time, so we have the most leverage on our crankshaft. You can actually get them to run at quite the range here of firing time, but there's a sweet spot. Everybody knows that. Sometimes we can fine tune it, especially once we make some upgrades on a truck. But this video is not about that. This video is about how easy it is to just drop them in without having to tune. So when we charge this primary field coil, it makes an electromagnetic field. When the ECU opens that circuit and says fire away, the magnetic field will collapse. When that field collapses, it's all around this conductor. It will induce a voltage. That's how we get from 12 volt systems to thousands of volts. We're not talking 5,000 volts, we're talking like 25, 30,000 volts. These electrons will get moving on this conductor, and they'll be looking for a path to ground. They're not going to head upstream to the positive side, so they're going to overcome this zener with their 20, 25,000, 30,000 volts. They're going to head down the spark plug and jump that gap where we see that high voltage reading if we were to plot it. Once it jumps that gap, it will have a spark event which has a little bit of duration. Again,
we're looking at things at a milliseconds time here. Not always perfect in there. That's why it matters so much that your ignition system is in good shape. Even if you're at 1,500, 2,000 RPM and you're looking for, you know, good performance, you're cruising, you want to benefit from a good spark light off and from good spark duration so you're not having blowout. We know our biggest problems on ignition are misfire in the total sense and partial misfire, which is much more common. When you have a total misfire, there's no missing it. We've all been there, we got to address it. Partial misfire, shocking how much people put up with this because it usually doesn't progress to be a problem overnight. It happens over time. Maybe you've got 50,000 miles on your truck. It's got some wear on it. Maybe fuel system's not running so perfect. You got a fuel injector that, you know, used to fire a pretty even atomized mist that went into a low pressure in your cylinder on the intake stroke, and that kind of atomized further. You know, in an ideal world, we would just have this homogeneous, perfect mix everywhere in the cylinder, nothing at a particulate scale, you know, that we would think is not perfect. Even when we compress all the way, again, we would hope it would be perfect. And we light it off, symmetry and balance in the chamber would be perfect. And our pressure could be tuned to run in and reach that ideal sense at the perfect time, and we'd burn it completely before we ever got to the cats. Some cylinders, a little more dysfunctional than others, you know? Like I said, some, they maybe got, you know, some problems. Their injector's got a few more miles on them, had some trash run through there, had a hard life. So they don't really start off perfect. Pretty common to have a fuel mix that's irregular in the chamber. A lot going on in there. So you may have a firing event that gets power stroke started and one flame front collides with another. Maybe you have blowout and the spark doesn't happen. Maybe it's a higher concentrated rich mix around the plug and you don't really get a good launch because now your peak KV is really high and you have a short duration. A lot of ways it can go wrong. The best way to get it right is to just give it more power all the time. That's always the answer. More power all the time. You know, you want to have this flame front propagate even, perfect, uniform. You want to have that ideal pressure at the right position as the crank's rolling. You want the most output, bang for your buck, right? Cruising, whether you're at, you know, idle 1,500 RPM, getting down the road just on the daily grind, or you're like full send at the track and you're running all the way 6,000, 7,000 RPM. Z1 coils are going to help get you there all the time. Without tuning even, same charge duration, same dwell time, Z1 coils are going to have significant more output. Some situations or applications it's 20% more at the max, some it's 60% more at the max. They're going to give you more spark all the time, no matter that charge duration. They're also going to reach what we call saturation sooner. That's the max charge cycle where we've kind of, as much of an electromagnetic field can be established has happened. Right? You're not going to get any more voltage out of it if you sit there and held it internal like longer, just cooking the coil. So this is a great solution that bolts in. It gives us more output. When we think of the energy ratings, 20% more, 60% more, think of that rating of joules like a string. If we take that string and plot it on our waveform, we can have a higher KV supported with still a longer spark duration. The blue graph kind of gives you an idea of what an OEM graph may look like. If things were tougher here and we pulled this event up higher, then this duration would be shortened. Maybe we don't have as much energy, heat, established connection running, and we have two flame fronts collide or something. They kind of partial blow that out. You get a shortened duration and maybe you don't get a complete burn. That partial misfire rears its head again. And you'll still have a longer duration for the full cycle. It's tougher to blow this spark out than the others, and should the event need, you know, to have a higher event, somehow we got a lot of fuel around there, or somebody breathed on it with a little bit of boost, we can still handle it at the same gap. And not blow out is easier, not have a shorter duration. So we see good, strong, cleaner burns. Just like what we saw on the dyno graph, we saw that benefit when we wheeled that out and drove it. Instantly the truck felt more alive, more responsive. It just felt fresh and new. You know, we saw the gains were there and we felt them in daily driving and all out when we wanted to lean on it. For us, the performance gain happened at the low end of the RPM band where static cylinder pressure, if you think about maybe like a compression test, is at its highest. When we see cams in an engine they have volumetric efficiency, and they have sweet spots in their rev range where they breathe. There is a sweet spot in each engine where they generate peak cylinder pressure, and that means more pressure, more compression in the cylinder. Usually that's from like a sweet spot where they have flow for intake and not too much leaking back out past valves as we convert to the compression strip. That sweet spot for us occurred, I think it was about 3,600 RPM. And that's the toughest compression spot for us to overcome here. We saw our biggest gains in performance on this test at that point. When the plugs came out, we looked at them and they looked pretty even as far as the gap goes. None looked really fouled. You look at the coils, they just look like old used ignition coils. Tough to just say, X-ray vision, yes, this one's a little worn on the inside. But we saw the gains nonetheless. We know that our output, improved performance, is what gets us there, gives us that benefit.
So now you know a little bit more about what's going on in there. Put more windings in these, as we mentioned. These, compared to brand new OEM set, have a plus 12% improvement on the peak output difference as they go across the dwell graph. Very nice upgrade. It will allow you to run your spark plugs at the same, or technically you may be able to extend their range, like the gap as they wear, they get a bigger gap. You may be able to cycle them out further. We haven't tested for fuel economy, but we do get a lot of feedback from our customers on other reviews about their fuel economy improvements, so something to consider looking at if you're doing the upgrade. Most of the time, if you're in it to win it, fuel economy is going to be like you're in it to win it, but if you drive the same exact thing like you do every day, adding an intake, adding a set of coils, and fresh plugs, not uncommon to get responses from a client that they're getting better mileage. So, plus 12%, these are also factory fit. This isn't anything rigged up where you've got to patch in with a harness, or have no way to retain the coil. It's a truck. Sometimes it gets driven over stuff that's maybe not perfectly smooth. You don't want to have a coil just stuck into a hole and hoping the pressure's going to keep it in place. You want to use the factory design flange and the hole on the valve cover to keep it bolted in. These kits also are divided. They have short and longs. The front ignition well, I believe, is a J. That's right, for our part number. Those are a little deeper, and then the rear wells on the engine are actually shorter. We've got you covered on that, so it fits perfect, just like factory. Nothing hanging out, nothing inappropriate. You don't want to mix them up. You'll probably realize you got a long guy sticking out that you can't bolt down if you've put a short one in the wrong hole. Double check your work. But if you get it all right, it's going to run great for you. You're going to enjoy it. It's a fantastic upgrade. Perfect to pair with a new set of plugs, maybe an intake or something else under hood. And our team's here and happy to help you with that. If you have questions on what's the right thing for your vehicle, whether you are just doing repair and maintenance, you need a good source on OEM or repair parts, or you want to make some upgrades, you're looking for a particular brand, we carry all the best, as well as a growing line of in-house offerings. So we've got you covered. We're happy to be here with you guys. We're enthusiasts just like you, and we hope you guys enjoyed this one. Let us know what you want to see next.